Thank you and good morning, everyone. Hope everybody is enjoying the conference. My name is Daniel Booth, and I'm a systems architect with CISCO Systems. I've been with CISCO about 17 years, and 10 of that I've spent in the public sector space working with utilities and government entities. One of the things that I want to talk about today is grid modernization. And I say grid modernization not as a buzzword, but how do we achieve grid modernization using technology? How do we leverage that technology best to ensure that the capabilities that you're looking to get out of your grid is really being achieved and realized? So as part of that, we're going to talk the why, the what, and the how. And with that is 5 pillars. And I say 5 pillars loosely because there can be more, and it's flexible depending on organization. But I would say that there's 5 that are foundational, are kind of core to a modernization event. Sustainability, and then how do we get from where we are today to where we want to be? So first, why grid modernization? Why is it important? Well, legacy grids were built years ago and didn't really account for the things that we need to today. Two-way energy flows, dealing with DERs, solar farms, EVs, all the things that we've heard about over the past few days. But let's add on to that the growing cybersecurity risk. This is something that plagues all of us, having to deal with both insider threats, but also outsider threats. And how do we manage those appropriately? And then being able to make real-time decisions, how to adapt the grid, and also how to adapt to our customers' needs. But doing all of this, realizing that sustainability is important. Sustainability is the key to everything that we talk about. So all of this starts upon what would be a secure digital infrastructure, an infrastructure that is purpose-built with security at the forefront to be able to provide that foundation for our grid and for all the utilities, or excuse me, the applications that we utilize to be able to deliver our services and provide, data, insights, services, etc. to our customers. It must be agile, and what I mean by that is we must be able to quickly deploy, quickly pivot, quickly roll out new technologies, new substations, power plants, services, but do that efficiently. And it is sometimes converging IT and OT. That is something that sometimes we look at and kind of stand away from. Carpeted space and uncarpeted space usually don't touch. But in the new world, it is something that we do have to look at, both of those becoming one, to where we look at IT and OT operations together. But again, doing everything based upon data. And that is key and critical. Being able to take data, run it through AI, run it through what is our business processes and business logic to be able to get tangible outcomes from the grid to be able to deliver. So, what is the first pillar? Something I will say here and something that I will say multiple times is security is foundational. The grid is a national security asset in a way. It is the foundation of what this country is. So we have to be able to protect it, and protecting it starts with keeping the bad guys out. Security isn't just about firewalls. It's not about blocking just an individual user, as we've historically thought about. It is about visibility end to end. In CISCO, that is cyber vision. That is getting assets and resources as close as possible to the substations, the solar farms, the battery banks, etc., to be able to have that visibility of what truly is going on in the environment. What's connecting, why is it connecting, what's it talking to, and ultimately, what's its purpose. Adding on to that visibility is segmentation. So being able to delineate between SCADA assets, AMI, corporate IT, third-party vendors, and any other systems that come onto the network, and being able to ensure that we can keep those systems, those resources segmented to be able to comply to regulatory standards. With that visibility and with that segmentation comes the ability to act on real-time threat detection. So being able to get telemetry out of the system, being able to know what's connected and its purpose, that allows us to automate that threat mitigation. Again, the grid is a national security asset, and we need to be able to pivot and be agile. And being able to look at a possible threat and take care of it immediately is something that is paramount in the grid of the future. Above security, it's being able to support what the distributed architecture has become. As I had opened up with, years ago, we looked at energy as a one-way flow, from the power plant to the house. EVs, solar farms have completely changed that. Now we have systems spread all across the regions that we serve, on residents' houses that we have to monitor and have to account for as we shift and pivot and adjust flows of electricity, but also deal with outages and ultimately that customer experience. We look at ruggedized platforms to be able to do that and be able to do that in many ways, giving flexible connectivity. Something that as a whole that we get used to is traditional means of connectivity. And being agile means thinking about methodologies like software-defined WAN, letting us leverage, instead of traditional fiber, our traditional point-to-point circuits that we've used, allowing us to utilize other infrastructure that's been built to connect all of these resources together, whether it be cellular, satellite, traditional commodity internet, or any other means, being able to get all of these distributed resources into our core infrastructure, so that way we get telemetry, we get data, we get insights, and we're able to action it. But action it in a way that's impactful to us from a business standpoint, and also us for our customers and the service that we're trying to provide to them. Automation. AI, automation is something that sometimes goes together, but it is paramount as we start to move forward. That starts with remote assets and being able to get telemetry and data out of those remote assets. And that also includes thinking about decentralizing our applications, decentralizing our compute, and getting resources as close to those DERs as possible. One of the great things about some of our platforms within Cisco is the ability to get edge compute right there next to our DERs, our solar farms, whatever it is, so that way telemetry doesn't have to rely on the network of the old, but it's able to leverage containerized applications running right there next to our resources and be able to take action immediately, whether that detect voltage irregularities and changing what needs to be done to rectify that, or trying to take care of a possible outage and reroute power, or anything that we're ultimately able to compute, train, and build into AI and what our computer applications. That's key to being able to respond without human interaction. One concern is always, what is actionable and does it get lost? And whenever we rely on centralized resources, and when I say that, a NOC or a SOC or a facility that's monitoring, we have to rely on that individual or group of individuals to see an alert and be able to take action on it. Is that efficient and is that scalable is the ultimate question. In some instances it may be, but in a lot we can leverage AI and automation to be able to take it out of the hands of somebody sitting in a facility, allow them to be leveraged more efficiently, and not have to rely on them fishing through 1,000 emails trying to catch one that identifies an alert that requires an action. It is building in automation to be able to detect those and take action without being dependent on an individual. And then we need to scale and grow that. Again, getting into distributed computing and AI, how do we add more and more automation to make the grid, the supporting infrastructure of the grid as well, intelligent and flexible? I talked about AI some, I'll talk about it a little bit more, but it is expanding ever so much. We've heard multiple speakers up here today talk about AI, vertical AI. How do we get AI into customer experience? And that's all going to be getting telemetry and data out of the systems in the field. That requires a solid network. That requires distributed resources. That requires cloud. That requires a lot. And that is why it is important to ensure that the devices, the infrastructure that we're putting in place is going to be able to support AI. And last but not least, and Tuesday I believe it was, in one of the panels, we were talking about customer experience and the importance of the customer. And especially for municipally owned utilities, customers are key stakeholders. But also, our business partners are key stakeholders. Our different business entities within our organizations are key stakeholders. And how do we ensure business continuity and business, the ability for our applications to serve our customers, whether that be internal customers or external customers? And that is observability. Being able to look real time at how an application that my customers are using is functioning, how those interactions are with us, whenever they're trying to call in, access our website, put in a ticket online, pay their bill, whatever it may be. In CISCO, we look at 3 tools for that. Thousand Eyes, to get that network visibility. How is the network operating? App Dynamics, how is the true application working? And then Splunk, the integration and aggregation of all that data to make intelligent decisions. The key here is being able to reduce outage times. Look at, is it a network issue? Is it a line of code? Is it one of any hundred of thousands of other things? And being able to rectify that quickly, again, trying to make sure that A, we're able to manage the grid appropriately, but B, that we are servicing our customers appropriately and making sure that their experience with us is 100% optimal 100% of the time. With any modernization effort, sustainability is always key. That's something that is almost a strategic differentiator in how we ensure that we are meeting those goals that have been set. There's 2 sides to that. There's first the hardware and the software that we deploy. And at CISCO, we pride ourselves in being able to deliver sustainable solutions and being able to enable your teams to be more sustainable, be more green, not have to roll trucks all the time, not have to have so many hands in the field, but again, trying to utilize resources better to reduce ultimately the carbon footprint. But it's also about that infrastructure being able to support us getting that telemetry out of the field, so that way whenever we talk compliance, we talk reporting, we can show tangible evidence of how we're meeting those goals because we're getting so much data out of the field based upon the infrastructure that we've built, the AI that we've put onto that to be able to crunch the data and give us the hard facts. So to close, we are at a pivotal time. Grids are modernizing, and technology is going to be key to that. And at CISCO, we look at everything as a partnership, and we want to partner. We have worked with utilities around the world on how to achieve grid modernization through the use of the networks, edge computing, security, observability. And we welcome the opportunity to work with all of you as partners. It is our customers collectively at the end of the day. It is all of us at the end of the day that we're trying to improve the experience of. And that is the goal of everything that we want to do with grid modernization, partnered together, is to make sure that the lights stay on and ultimately all the customers are serviced and satisfied. Thank you so much. I hope everybody enjoys the rest of the conference. Have a great rest of the day.